Assalamualaikum and good day everyone. So today we are going into the second part of stoichiometry. Okay, so in previous video you have learned on how to use the stoichiometry relationship to look for the things that you want based on the given information to you. Okay, so basically from the learning outcome here you have covered for the part A. So now we are going into the definition and also the perform calculation part. However, we are going to focus only on the limiting reactant and also the perform calculation punya bahagian pun we are going to focus on only the limiting reactant part. Okay, so now let's have a look at what is limiting reactant. Okay, so it is very important for you to understand the definition of limiting reactant and for you to know the meaning of the limiting reactant itself. So what is limiting reactant? So basically limiting reactant is reactant that is completely consumed. Completely consumed bermaksud it is completely reacted, okay, in a reaction and limits the amount of product formed. So ada two main point dekat sini. First one is reactant is completely consumed and also it limits the amount of product formed. Bermaksud dia yang akan determine how much the product will be produced. Okay, and then meanwhile kalau ada satu yang dipanggil sebagai limiting reactant, there will be another one, satu lagi reactant pula, that one kita akan panggil sebagai excess reactant. So I hope you know what is excess. Excess bermaksud macam ada berlebihan kan. Okay, so excess reactant untuk ini pula, it is reactant that is not completely consumed in a reaction. Okay, so dia terbalik dengan limiting reactant. So not completely consumed and remains at the end of the reaction. Bermaksud ada baki. By the time kamu reaction tu dah stop, bila tengok, oh ada lagi, excess reactant tu masih ada lagi. Okay, so dia tak 100% digunakan. Meanwhile, kalau limiting reactant pula, it is 100% used up. Okay, in a reaction. Okay, so very important, okay, for you to remember the definition of the limiting reactant because benda ni akan membantu kamu. Kalau kamu faham konsep limiting reactant ni, it will really help you out during calculation part. Okay, so basically let's have a look at the production of car dekat sini. So in order to produce a car, what we need is of course the car body. Okay, and one car body akan memerlukan at least 4 tire. Kita abaikan the spare tire. Okay, so how many cars can be produced based on the given materials to you? Okay, so ada dua reactant kat sini lah. Kita anggap the car body adalah one reactant, then tire tu adalah another reactant. Remember what is reactant? Reactant is the one on the left side of the equation. Okay, so this part is kita punya hasil pula, kita punya product. So as you can see, kita boleh hasilkan 8 cars, but then we have 16 tires in excess. Okay, bermaksud 16 tire tu adalah baki sebenarnya. So it remains at the end. So as you can see, the tires, some of the tires remains at the end. Okay, bermaksud the tires are not completely consumed. Kita tak habis guna pakai yang tu. Therefore, tires dekat sini is considered sebagai excess reactant. Sebab ada baki dekat hujung kan? And kita tak pakai habis pun. Meanwhile, ada tak baki untuk car bodies? Ada tak kamu nampak car bodies kat sini? Tak ada. Okay, so since dia tak ada baki, bermaksud we completely use the car body. Therefore, car body kat sini pula is considered as limiting reactant. Okay, so basically the car bodies, it limits the formation of the products. As you can see, we can only produce 8 cars because we only have 8 car bodies. Okay, however, the tires pula tak habis diguna pakai sebab dia ada berlebihan. Okay, so kita boleh nampak lah ada baki dekat hujung ni nanti. Okay, so yang ni in terms of kalau kamu nampak production kereta ataupun kamu boleh try imagine kalau kamu nak buat burger, nak buat satu burger, kamu perlukan 2 keping roti dengan 1 burger daging tu. Tapi kamu ada 5 jak roti dan kamu ada 2 jak kepingan daging burger tu. So berapa banyak jak burger yang kamu boleh hasilkan? Try fikir sendiri. Okay, so fikirkan yang mana yang limiting, yang mana yang in excess. Okay, so this one pula in terms of chemistry. So let's say you have the red reactant reacts with the green reactant. So it will produce the blue product and also the purple product. But then at the end of the reaction, you can also see, oh ada merah ni ada baki. Okay, so kalau dia ada leftover reactant, therefore the red one is considered as the excess reactant, meanwhile the green one is considered as the limiting reactant. As you can see, there is no green reactant left at the end of the reaction, meaning the green reactant has been completely used up. Okay, and the green reactant is actually the one that limits the amount of product formed. By the time green ni habis, reaction will stop. Okay, so sebab merah ni dah tak ada, dia tak ada green dah untuk dia react untuk hasilkan the product kan, so reaction akan stop lah dekat situ. Okay, so now kita nak tengok example lah. So how exactly kita nak determine limiting product in terms of chemistry pula. Okay, and then kita nak try kira sekarang lah. Okay, so given to you that S reacts with fluorine will produce SF6. Okay, so if 4 mole of S reacts with 10 mole of F2, which of the two reactants is the limiting reagent? So you have to figure out whether S is the limiting reactant or fluorine is the limiting reactant. Okay, so how do we do this? So we are going to compare the amount of available, okay, which is given to you, and needed reactant. Okay, so given to you is 4 mole of S reacts with 10 mole of F2. Okay, meaning this is the given information to you, but now you have to look for the needed mole. So how exactly we are going to use that, to do that? So we are going to use kita punya skill waktu nak guna apa? Waktu kita guna stoichiometry relationship. Okay, bermaksud ada kaitan dengan equation kat sini lah. So equation kena balance. Okay. Okay, so first of all, what you have to do is to extract out all the information given to you. Okay, so sorry, misalkan salin balik di equation. Okay, so now kita keluarkan information. So given to you that there is a 4 mole of S, okay, and also 10 mole of F2. Okay, so let's write that down. Okay, so kita ada 4 mole and ada 10 mole untuk F2. So this is basically the given mole to you. So labelkan. Okay, labelkan that this is the given mole to you. Ataupun kalau kamu nak tulis properly macam okay, so NS equals to N2 mole lah kan, 4 mole. So ini given. And then kamu nak keluarkan N untuk fluorine adalah 10 mole. So ini adalah given juga. Okay, so now kita akan guna stoichiometry relationship antara sulfur and also fluorine. Okay, so from the balance equation, so we have 1 mole of sulfur reacts with 3 mole of fluorine. Okay, but then given to you, you only have 4 mole of sulfur and also 10 mole of fluorine. So kita guna salah satu info. Okay, so let's say kamu nak guna sulfur, letak sulfur, okay, gunakan sulfur dekat sini. So tulis sulfur punya mole kat sini, tapi untuk F2 dia akan jadi unknown. Okay, so if you are going to use fluorine punya given mole, so kamu letak dekat bahagian ni nanti. Okay, but then the unknown one adalah akan jadi kamu punya sulfur. So pilih satu je. Okay, pilih satu je. Usually misalkan ambil yang belakang tu sebagai unknown lah. So kita ada 4 mole je kan, but then we have only 4 mole of sulfur. Okay, therefore kita akan ada X mole of F2. Okay, so X mole dekat sini adalah kita punya needed mole untuk F2. Okay, nanti kita akan buat comparison. Okay, so now we are going to look for the X kan. So 1 bahagi 4 equals to 3 divided by X. Therefore, X is equals to 3 times 4. So you get 12 mole. Siapa punya mole ni kelas? Okay, so ini adalah mole untuk F2. Okay, jadi labelkan properly dan. Okay, so NF2. Is this given mole ataupun needed mole? This is needed mole. So if we use 4 mole of sulfur, meaning we need 12 mole of F2. Okay, so now kita comparekan the needed mole of F2 dengan the given mole of F2. Okay, so kita compare satu je lah. Kita compare sekali je. Tak payahlah compare untuk sulfur juga. No, tak perlu. Buat sekali je cukup. Because by the time kamu buat comparison sekali, kamu akan boleh determine whether the reactant is actually limiting ataupun excess. Because if F2 adalah limiting, automatically sulfur will become the excess. Or if F2 adalah excess, bermaksud sulfur will be the limiting. Okay, so now kelas kita nak compare tadi kan. So basically kita ambil yang mole needed ni. So mole F2 needed, kita compare dengan mole F2 given. Okay, so adakah dia lagi banyak ataupun lagi sikit? So needed ada 12. Given pula ada 10. So the needed one adalah lagi banyak daripada given. So class, if yang kamu perlukan lagi banyak daripada apa yang kamu ada, habis tak apa yang kamu ada tu? Okay, fikirkan. So kalau yang kamu perlukan lagi kurang daripada apa yang kamu ada, habis tak? Ke ada baki? So benda tu kamu kena fikir. So basically, if yang kamu perlukan melebihi daripada apa yang kamu ada, basically the one yang kamu ada tu akan totally habis. So bila dia totally habis, meaning kita punya F2 dekat sini. So kita buat conclusion. So F2 is the limiting reactant. Okay, settle. Dah menjawab. So all these statements are very important. Okay, the part yang kamu compare dekat sini is important. The part yang kamu buat conclusion kat sini, whether F2 is actually limiting ataupun excess, is also important. But if kamu dapat jumpa yang F2 ni sebenarnya adalah excess reactant, okay, so adakah kamu dah menjawab soalan? No, belum lagi, sebab soalan tanya pasal yang mana satu limiting reactant. So kamu kena tambah another statement that yang S pula adalah limiting reactant. Okay, it depends lah. Tapi in this case, since kamu terus jumpa yang F2 adalah limiting reactant, settle. Okay, so perlu tak nak buat comparison pula? Kita guna pula macam apa ni? Sini kita guna 10 mol, sini pula jadi X. No, tak perlu. Okay, cukup sekali je kamu buat comparison, automatically you will find that one of the reactant will be the limiting reactant. Okay, so this is untuk example 1. Okay, so basically kita boleh conclude kan kelas, kita boleh conclude yang if mole A needed more than mole A given, so dia macam sama case dengan fluorine ni tadi kan. So we know that A is limiting reactant. Okay, but then if kita punya mole A needed is less than mole A given, therefore A is the excess reactant. Okay, so kamu kena ingatlah benda ni. Tapi as long as kamu faham sebenarnya konsep limiting reactant ni macam mana, it shouldn't be any problem. Okay, so let's have a look at the example 2 now. Okay, example 2. Okay, so C is prepared by reacting A and B. Okay, so kita ada, dia dah bagi dekat kamu equation dekat sini, where A plus 5B menghasilkan C. Therefore, given to you that in one reaction, okay, you have been given 2 mole of A, it will react with 9 mole of B. Dan ada beberapa soalan dekat sini. The first one is to determine the limiting reactant. Okay, whether A ataupun B. Okay, jangan kamu pergi fikir pasal C pula. No, C dekat bahagian sebelah kanan reaction. So that is a product. It's not reactant. Okay, so it is either A or B. You have to determine whether A ataupun B adalah limiting reactant, and you have to calculate the number of mole untuk C. Okay, based on jawapan kamu daripada A. Okay, kalau A kamu salah, B kamu pun ada possibility salah, and C kamu pun ada possibility salah. Okay, and then dia tanya pula how much of the excess reactant left at the end of reaction. So since kamu dah jumpa limiting waktu dekat A ni tadi, bermaksud automatically you know siapa excess. So kamu kena cari baki dia dekat hujung tu pula. Okay, so baki dia mesti lagi sikit daripada apa yang diberi kepada kamu lah. Okay, lepas ni kita akan tengok. Right, so now let's extract out all the information given to you. Okay, so given to you that you have A plus 5B menghasilkan C. Okay, so mole A adalah bersamaan dengan 2 mole. Mole B adalah bersamaan dengan 9 mole. Okay, so keep in your mind that this is a given mole. Ini pun adalah given mole juga. Alright. Okay, so now we need to determine the limiting reactant. Okay, so kita nak buat apa ni? Kita tulis from equation lah. So from equation, okay, we can see that 1 mole of A reacts with 5 mole of B. Okay, again it's up to you, kamu nak ambil yang mole A given kah ataupun kamu nak guna mole B given kah. Okay, and then one of them akan jadi unknown. Okay, so Miss just ambil senang, kita ambil yang mole A je lah. Okay, so since mole A ada 2 mole of A, okay, bermaksud kita punya B would be X mole then. Okay, therefore kita nak cari X value X is 2, so 1 divided by 2 equals to 5 divided by X, therefore X is equals to 5 times 2, so you get 10 mole dekat sini. Okay, so 10 mole ni mole siapa sebenarnya kelas? Okay, so labelkan, label please. Okay, so ini adalah mole untuk B, so given kan needed ni, this is a needed mole. Okay, keep in your mind that the unknown mole yang kamu dapat daripada kamu punya stoichiometry relationship ni, that is the needed mole. Okay, so if kita ada 2 mole of A, we need 10 mole of B. However, do we have 10 mole of B? So let's compare untuk tahu dia adalah limiting ataupun excess. So now since kamu dah jumpa mole B needed, so kita nak compare dengan mole B given. Okay, so given mole untuk B adalah 9, needed 10, maksud needed lagi besar. So what is B class? Therefore B is, since yang kita perlukan lagi banyak daripada apa yang kita ada, habislah kan. So B is limiting reactant. Okay, so settle. Okay, so kita dah settle untuk A. And the next question is, dia tanya calculate the number of mole of C. Okay, so kalau kita tengok balik equation class, okay, so kita ada A dengan B menghasilkan C. But then, siapa yang akan tentukan berapa banyak C terhasil? So, the one yang akan tentukan berapa banyak C terhasil is B. Kenapa B? Because B is the limiting reactant. Kan kamu dah cari tadi dekat bahagian A, kan? Kamu dah cari dekat part A where B is the limiting reactant. Therefore, B yang akan tentukan berapa banyak C yang terhasil. Jadi, bila kamu nak tentukan pula the amount of C kat sini, sekali lagi we need to do the stoichiometry relationship. Okay, but you have to do relationship between B and C. If you use A and C, adakah betul? Salah. Because A adalah excess reactant, dia tak akan tentukan berapa banyak C yang terhasil. Okay, so kita kena guna B dekat bahagian sini. Comparison kamu kena between B and C. Okay, or else kamu akan jadi salah nanti. So 5 mole of B produces 1 mole of C. Okay, the next question is, so which one nak pakai ni? Mole needed ke mole given? Kan tadi kamu dah jumpa mole needed untuk B adalah 10, mole given untuk B adalah 9. Please class, keep in your mind apa yang kamu ada. The one yang kamu ada adalah given, yang kamu ada 9 mole. Kamu tak ada 10 mole tu, you have only 9 mole. Therefore, make sure you use 9 mole dekat sini, bukannya 10 untuk yang B ni. Okay, so 9 mole of B produces, so misalnya tak Y lah pula, unknown yang lain pula, Y mole of C. So you need to look for the C lah now. Okay, so basically 5 divided by 9. 5 divided by 9 is equals to 1 divided by Y. Therefore, Y is equals to 9 divided by 5. You will get 1.8 mole. Okay, so ini adalah mole of C. Settle. Okay, dah settle kat sini. Labelkan je lah. Okay, so kita dah jumpa the amount of C that is being produced daripada reaction of A and B. Okay, and then the last one, the last question is, how much of the excess reactant is left at the end of the reaction? Okay, so since B adalah limiting reactant, therefore kita tahu yang A adalah excess reactant. Okay, so keep in your mind that mole left at the end of reaction is basically equals to mol untuk kita punya excess. Okay, mol excess yang given. Okay, mol excess given tolak dengan mol excess needed. Okay, so kamu kena take note lah apa yang kamu dah ada sekarang ni. Okay, so the only thing yang kamu ada sekarang ni adalah mol excess given. Okay, yang mol excess given tadi adalah kita punya 2 mol dekat sini. Itu adalah given to you. However, do you have mol of A yang needed punya? Tak ada kan? Therefore, you have to do sekali lagi kamu kena buat stoichiometry relationship. Okay, antara A dengan B. Tapi sekarang ni siapa unknown kamu? Unknown kamu sekarang ni would be bahagian A. Okay, bahagian A ni unknown untuk kamu cari needed dia. Okay, so now kamu nak kena buat from equation lagi. So from equation, basically again sekali lagi 1 mol of A reacts with 5 mol of B. Okay, but then kita ada 9 mol of B, therefore kita ada Z mol of A. Okay, whereby Z is equals to, kamu akan dapat Z equals to 9 divided by 5, so you will get 1.8 mol dekat sini. Mol siapa ni? Ini adalah mol of A. Mol apa? Needed. Okay, so since you have the mol needed already, so now you can look for the mol left at the end of the reaction because you already have the given and you also have the needed part. Okay, therefore kamu akan dapat, kena kira lah lagi, belum habis lagi kan. Okay, so mol A at the end of reaction equals to mol A given minus mol A needed. So you will get 2 divide pula minus 1.8, so you get 0.2 mol. Okay, so ini adalah mol of A. Dah sekali tu nanti. Okay, jadi settle dah. Okay, but I have a question to you now. So ini adalah mol untuk A, excess reactant, ada baki, which is 0.2. So at the end of reaction, now once the reaction stop. So what about mol of B at the end of reaction? Dia ada berapa banyak? What is the amount of B at the end of reaction? Okay, so try to think of the answer for this. I will tell you at the end of the reaction. I will tell you at the end of the video. Okay, so now let's have a look at soalan try this lah. For it is your turn to try. Okay, but just keep in your mind the examples given to you here adalah dalam amount dia dalam bentuk mol, so agak straightforward. But then in the question you might not be given dalam bentuk mol, you might be given in terms of mass, you might be given in terms of volume ataupun molarity. Okay, where you have to convert it into mol dahulu, cari dulu mol dia, baru kena buat stoichiometry relationship semua. Okay, lagi extra susah sikit kalau dia minta buat equation dahulu, balancekan equation dulu, baru nak kena buat benda lain. Okay, so always double check sama ada equation dah balance ataupun tidak dululah, baru kamu boleh proceed with all the calculation part. Okay, so let's have a look at the try this question. Alright, try this 7.0. Yang ni tak ada masalah sangat, kamu boleh try sendiri, baca soalan, and it's quite straightforward because given to you is dalam bentuk mol juga. Okay, and you have been given the final answer untuk part 2. Okay, so kalau limiting reactant kamu salah, so most probably your answer part 2 will be salah juga. Okay, so make sure you determine the right limiting reactant in order to get the correct answer for part 2. Okay, and then I don't think there's any problem with try this 8.0 as well. You can try on your own. Okay, but for question 9, try this 9.0. It's a bit tricky. Kenapa it's a bit tricky? Okay, you can read on your own the question part. Okay, cuma Miss nak start dekat bahagian if ni. Okay, so if 103 gram of CCl4 is mixed with 95 gram of SbF3, so calculate the amount of CCl2F2 obtained. So CCl2F2 adalah bahagian product. Okay, Okay, so kita tengok sekali lagi info yang diberi. So given to you adalah 130 gram of CCl4, 95 gram of SPF3. Okay, jadi kamu nak tentukan berapa banyak CCl2F2 yang terhasil. Okay, tapi sekarang ni kamu nak guna info yang mana? Do you want to use the info of CCl4 or SPF3? Okay, soalan memang dia minta CCl2F2 punya jawapan, tapi dia dah bagi info kat kamu dua-dua reactant dekat sini. Tapi kamu nak kena pilih yang mana yang boleh tentukan berapa banyak CCl2F2 yang terhasil. Jadi ada something yang kamu kena buat dahulu. There's something that you have to determine first in order for you to determine the amount of the CCl2 being obtained here. Okay, so try figure out. So ada something yang dia tak minta kamu cari, tapi kamu kena buat dulu. Lepas tu baru kamu boleh cari the amount of product form. Okay, so this one is a bit tricky because dia tak guide kamu apa steps yang kena dibuat. Tiba-tiba dia minta product jar. Okay, so be careful. Okay, because given info to you adalah pasal dua-dua reactant, tapi only one of the reactant yang akan determine berapa banyak CCl2F2 ni terhasil, and that reactant is what we call as kita asyik sebut dia hari ni kan, nanti kamu try determine sendiri. Okay, so back to my question just now, tadi pasal A dengan B tadi kan. So tadi A yang untuk example 2 tu bagi dia adalah 0.2 mol at the end of reaction, but misalnya what about B pula? So what is the amount of B at the end of reaction? So I hope you have the answer, and the answer is 0 mol. Okay, kenapa 0? Because it is completely consumed, it is completely used up, therefore tak ada baki. Kalau tak ada baki bermaksud 0 mol. Okay, alright, that's all class. Okay, Assalamualaikum, bye bye. Nanti try 3 soalan ni.